Hey guys, this is Steven from LegitTechTutorials, and welcome back to our product design series. We're back again working at the multi-extruder expansion control modules. So this past week I've printed a few of the parts. I've printed the big parts, I've printed the dimensional control bracket that we've been working on, and I've printed the spooler module, right? Spooler module came out great. This came out perfect. No issues with the overhang. It was a little rough here on the bottom, but it came out fine. Other than that, it came out fine. Everything else came out fine because at Tech Shop they just fixed the MakerBot and they put on a new nozzle, new hot end, and also a new heater cartridge, I believe. So now it prints great. And also they got the part cooling fan to work. So now the part cooling fan works with its own little funnel and pushes air down here to cool it, so it's better at overhangs now. And also this is looking the fill looks absolutely beautiful. I have the piece over here. I mean, I have a little bit of curling, so I need to get it to stick down a little more, but it has perfect sides. The overhang is pretty good. It's a little ripply, as you can hear there. It's a little ripply, that's where we're going to install the part we're going to make today. But other than that, it looks good. The place where we're going to put the load cell looks good. And I do have those load cells ordered. They are on their way. I also just ordered the motors for these guys. They're on their way. And I ordered the servos that are going to be for the part we're going to make today. Those are also on their way. Alright, so this guy, we printed this guy, and it's right here. This guy is another story. This guy, I had supports for this piece right here, and just super annoying, this part here, the supports. So, hopefully I could at least do it where I could do this piece here without supports, and then maybe delete this top piece here, preferably. But I'm definitely gonna need to change it because the supports are just no go. Not unless I had something like a more intuitive software than the Makerware. Because take these supports out. I mean, I'm gonna actually give it a. I was giving it a try with like the part scraper that scrapes the part off the bed, but I'm gonna have to give it a try with some what's it called, needle nose pliers, or have one of my friends has what's it called, a Simplify 3D, so I might have to have him go in here and design this, cut this part for MakerBot, and then go from there. I might have to do that because he says that the supports and Simplify just come off so easy. So I also might have to do that. We'll see. I mean, if I have to, I'll just have to delete this top portion here. Other than that, everything looks, I mean, it's perfect along the side. I got a little bit of bending. I got a little bit of warping here because it's a long part. Other than that, it looks good. So again, the supports, like I said, were for these two pieces. So maybe I might just get rid of this top piece, or and then just try to print this without support. So I might just do another print where I just try to get that to work. And also I might, for this next print, what I'll probably do is I'll probably just put a plane here and then delete this part and then just have it print this back. See how that comes out, so I don't have to waste so much plastic. Alright, but it looks pretty good. I just have to fix that down there, and then it's ready for the load cell. And like I said, I just bought those load cells, and then the HX711, which will sit up here or back here or somewhere, or maybe in this corner. I'll have it they'll back tape this corner, and then you have the wires coming into it, and then you're good to go. Alright, so yeah, so what we're gonna do right now is we're gonna do the actual winder, the filament winder. So the filament winder is the part that wraps it onto the spool. So I know that if you've done any 3D printing, you've seen a spool where the filament is wrapped onto the spool all the way across. So you need something to direct the filament back and forth to wrap it on the spool, so we get the maximum amount of stuff that is wrapped onto the spool. So what that's going to use is that's going to use a servo, and the servo is going to go back and forth on it, and then it's going to wrap it onto the spool. So that being said, it's going to be dynamic to where it allows it to wrap onto the spool different size spools. So it'll be able to go, back and forth. I don't know exactly how to explain it. It's going to be able to, so if the spool is basically up to this piece or up to this piece, it'll go full throw. But if it's a smaller spool, then it will go. Then you could change in the software the maximum throw of the servo, and it'll only bounce between these two places. So this piece is going to basically mount onto this piece right here. So I'm going to have a little square like this and a square like this. And then out here is going to have like, I might just bolt on a piece of, what I might do is I might just bolt on a piece of extrusion, or maybe I might model a piece of extrusion that goes on there. So there'll be like there'll be like a square here that you super glue or bolt it. I might bolt it, I might do something. Bolt the two pieces on here so they're nice and straight, and then I'll have like a piece of extrusion that goes across, and then this thing will go back and forth like that. And then on the servo, it'll have just like a little horn thing that has a hole in it, and the filament will go through that hole, and then it will push and pull the filament around. So hopefully the servos that I bought will work. At 5 volt, they get about 1.5 kilograms per centimeter. So I want to have, also they do about a 180 throw, half rotation. They're half rotation servos. Estimated, they probably make plus or minus 180. They could do somewhere around there. They might do, I'm gonna guess, if it was anything, it was gonna be less than 180 degrees. So also, like I said, the gearing that I want to do, it has to be less than, I want it to be to where I have the gear set exactly, so because the bigger the gear, the less force I could output on the center, on the edge, because the piece is 1.5 kilograms per centimeter. That is a torque. So you divide that by the centimeter distance from the center to the radius of the gear, and then that is your force at the edge. So I want to have it to where the gear is the smallest it could be, so that I don't lose so much torque. So this is the winder. Okay, so now that we got this, what I'm going to start off with is I'm going to start off with going to this guy and then finding the distance between here and there. 88.90 millimeters. This is going to be 3D printed, so let's just go ahead. And I said 88.90 millimeters, right? 88.90, okay. 88.90. Okay. 44.45. So this is going to be 44.45. Okay, so now that's the bounds. Oops. now we're going to do a rectangle. I'm just going to draw a line and then draw a rectangle off that point. Here it's looking like 19.05. 9.525. What was it? 9.525. 9.525. And then I'm going to do the rectangle. First thing, I'm going to move this guy out of the way. Rectangle. And this one is 19.05. 19. All right. Okay, same thing over here. 9.525. 19.05. 19.05. 19.05. Alright. So those are our two pieces, and then these mount again here and here. Now what I'll do is I'll extrude these. These probably need to be maximum 0.25 inch. Yeah, 1/4 inch would be fine. Okay, and then on top is the piece that's going to mount the piece that goes across. So now's the question of how exactly am I going to do this? So what I'm thinking is because I do kind of like the way that because for the let me show you guys what I'm thinking about. Here's the Filament Winder. So here's how the fill extruder handles it. So they handle it with like this little servo thing that goes back and forth with this piece, but he's got a fat servo on there. I have a really small servo. I mean, I guess that would work. So yeah, there's a better view of it. So yeah, he's got a full size, like $20 servo there. It's pretty long. But yeah, back and forth here. So as you see here, it winds it back and forth. And then this little dial here controls the throw of the servo. So you can get it to work with any size spool. That being said, so mine, I was thinking about having a little piece that goes back and forth like that. But this is actually, I mean, this is sort of... Alright, well, let's do some modeling of it then. And we'll figure this out. Alright, so let's just say that it has a square that goes between this guy. So let's just say that this was solid. Okay, so let's just say that that's solid. And then we have a sketch on top from right here, and let's just say that there was a hole. I don't have a servo to go off of right now, so I'm just gonna guesstimate and then fix this later. So there was a circular hole about that big or whatever. And then you know what I'm going to do is I'm going to stop this sketch. I'm going to do that on the first sketch. Delete sketch. Edit sketch. I don't think it really has to be that big to get that horn through. So let's just do that. All right. So there it is. And then basically what pops out is the horn piece, right? So I'm going to create another sketch off to the side, and then we would have a horn piece that in order to get all the way to the corner, and again also we only want it to push, right? We don't want it to like get caught at the top. So like if you look here, we don't want it to get caught up here, because then it would put pressure on this, because this guy's pulling taunt. This guy's pulling with high force, so you want to make sure that it doesn't hit this top piece, because now you're taking up slack there and it's gonna break. It's gonna put a lot of stress on my little plastic gear servo on the horn piece, on the shaft and on those bearings in the shaft, because it's trying to pull this thing off with quite a bit of force, with 2 pounds or more force. So anyways, so now we have to think of, okay, this is our maximum here. Our maximum spool size is basically 89 millimeters. So in order to do 89 millimeters, oops. Alright, so let's do, I'll draw the trig out here for you guys. So we need to do, at least this guy needs to be, actually, so I don't even need to do trig. I could just draw it in here and it would figure it out. So this is going to be 89 millimeters, right? How big and I want this to be as short as possible, so here they have theirs very very long. So how would that fit on here? So what it's going to do is it's going to attach here, and then the servo is going to go down. It's basically going to go down down below. So the servo is going to attach up here. Yep, for this design, this particular design, it's going to attach up here, and then the servo piece is going to be down here, right? So I might actually have to have this kind of be like a weird shape in order to pitch it so that this goes 45 degrees down this way. Because this is 60 and it needs to do like a weird downwards thing. So we'll worry about that later. But so it needs to go 89 millimeters this way, or I guess it's 44.5, and then this is 44.5. Okay, so you have those two, and then it has to be able to cover that basis. So you'd have, you know, a line that would be, so let's just draw a giant tangent line there, a giant 90 there, and a giant 90 here. So it's gonna have to go like this or anywhere in here. And then the longer it is, so this is 6.7 centimeters. So that is 1.5 divided by 6.7. So that's only half a pound of torque at that point. So the smallest but yeah, see, now if this is the case, what I'm thinking I'm going to do is I'm just going to have it like this, and then I'm going to have, you can't have a hole though, because then it would, yeah, then it would bind again. It would do a weird binding thing. It's going to have to be how they have it, like this, and then sweep. Like this and then sweep. Okay, well, let's just say let's just say that it's that long then. Okay, that long, and then we're gonna have like a little circle at the top. We're only going to do half of it, of course, of the circle. And we're going to draw a rectangle. Oh. Let's have the hole needs to do at least 3 mil. So that would be 5 mil. Okay. Somewhere around there. Yeah, so let's have it. And then let me see if I can get the trim. Oh, I could just do coincide this. There we go. And this is going to be perpendicular to this one to this one. Oh, it's got a 90 there, so should be perpendicular because it's 90 down here. Huh. Alright, and then we'll do a little circle off the center here and have it attached there. And so now when we extrude this, yeah. Alright, stop, sketch, extrude. And then make that 1/4 inch. Alrighty. Oh, but that was supposed to be a slot. Herp. So I'm gonna do an offset. thick, 0.1 inch, negative 0.1 inch. Wow. That one on the Phillips screwer is about, that one's probably almost ½ inch. I go for that. Let's see, quarter inch. And so it is going to be a little longer, but that's okay. Offset 0.25 inch. I don't know what the hell this thing. I don't know how that happened. But I like it. Let's fill that guy in. Whoop. I actually wanted to do that, sorry. And then have these not be filled in. Oh shit. Okay, not that one then. Oh, something's missing. That should be good. Alright. Yeah, it looks almost exactly like theirs. Except for that there's a lot thicker. Okay. So, maximum here. We are looking at 7.1 centimeters. So 1.5 divided by 7.157 centimeters. That's only 0.2 kilograms, which is half a pound. So hopefully it doesn't actually I'm gonna be honest, it doesn't look like that design will work very well. I'm looking at the picture on my other screen here. I don't know, this design just does not look like it would work well. I think going back and forth would be ideal. Here's what we'll do. We'll do something pretty cool. I'm gonna change that design a little bit. So let's just put this on hold for right now. This guy here. Let's see if we could do something else. All right. So now, what's gonna happen is because I'll keep a lot of torque if I do this. Okay, so we're gonna go back to this guy. Edit sketch. I'm gonna delete these two. I'm gonna delete these two. I'm going to delete that. Oop, probably don't want to delete that. Okay. Now, whoa, this is a jumbled mess. Oops. Okay. So now what I'm going to do is instead I'm going to make a bar that's going to go across this guy. And it's going to have to do quite a bit of stress. So I'm going to say you're going to have to go a half inch. Let's do it. Half inch. So up here, 0.25. Is that bigger than our box though? No. Okay, that looks perfect. Okay. Now this is going to be a rectangle from here to there. And this guy is 0.25 in. This is half inch. Boom. Alright. We might have to do 2 extrusions on this guy, because I don't know if I want that guy to be exactly half inch. I might have it be, I don't know if I exactly want it to be 1/4 inch. I might have it be half inch. So let's just edit these. Oops, not that. Edit this feature. Have that half inch. Do another extrusion before those 2 come up, and show the sketch again. Boom, boom. This guy, 0.5 inch. All right. So now we're gonna do some cool stuff. What I'll do. We're over time a little bit, but what's the angle of these 2? Well, it's 90. What's the angle between this and this? Oh my god. That's not what I'm asking. There you go. 40 degrees. Let's have this guy go off from this corner about 4 or 5 degrees. And to that point, this one's also 4 or 5 degrees. There you go. Okay. So now what I'm gonna do is do rectangular pattern tool. Boom, boom. Directions that way. Okay. Then I'm gonna have to do a shitload of them. Spacing. And there you go. Stop sketch. And then I'm going to extrude. Oops. Bam. And there we go. There's our little geared piece. And then what would happen is the servo would ride on the top. The servo would be on the top with a gear. And then there would be a little bearing piece on the bottom with like a little flange that hits the front here, grinds or whatever. And then that would do what we're trying to do. Or it might do like a little box thing where it has bearings on all the sides and then you attach the thing on it. Who knows? But with this, I'm going to maintain most of that torque, because in order to go this distance, which is 89 millimeters, so let me see. Let me do this really quickly. I'm way over time. Okay, it's 2 pi r, but it's not going to be 2 pi because we're only going half circle. So 2 pi r is equal to 89, so 89 divided by pi. My pi on here. Oops, 89 divided by. Jeez. So 28 millimeters. So let's go ahead and edit the sketch, see how big that is. 28 millimeter radius. So it's going to be a freaking huge gear. So that's the size of the gear, because it's doing half rotation. But if we have a 28 millimeter radius, that means we only have a 2.8 centimeter distance there for the arm. So that means at the tooth, so that means that at these teeth here, we could do 1.5 divided by 2.8 equals. So that we still have half of our original torque. We have 0.5, and so that's 1.17 pounds. So instead of half a pound, now we have 1.7 pounds of force that we put down on these teeth. Alright, so that is pretty much it. I might have to look for maybe like a full rotation one that has that same torque. So it'd be really nice to have 14. That would be really nice. And then because that would double our torque, which means we have 2.35 pounds. So that's around 1 kilogram. A little bit over 1 kilogram. So and the issue is that I just ordered those. I probably should have done this first before I ordered those. But it's like $20, not really a big deal. Alright. So it's been Steven from LegitTechTutorials. Thank you guys for watching. If you like this video, please subscribe for more reviews like it in this series and our series as well. See you guys next video. Thanks for watching. Take it easy. Peace.